Good afternoon, everybody, and welcome to the Fluid Power with InduSoft Web Studio webinar. My name is Fabio Teresino. I'll be co-hosting this webinar with Matt Lindemann, responsible for the OEM products for Dakota Fluid Power. I'll provide a very quick introduction about the architecture of the system and the main technology used in the project. And then I will hand over to Matt, and he will provide a brief introduction about Dakota Fluid Power, and he will demonstrate how they designed their remote monitoring system and controlling system for the RTUs using InduSoft Web Studio. So, from a very high-level point of view, this is the main architecture of the system. Dakota Fluid Power has several RTUs distributed through many different locations, geographically speaking. So they wanted to have the ability to consolidate information from all those RTUs in a central database and create a system that could work as a portal for remote users, the owners or responsibles for each one of those RTUs, to be able to monitor online data and history data remotely, or even trigger commands from remote web browsers to each one of the RTUs. So they have a local HMI on each one of the RTUs, but they also have a cloud-based system, a cloud-based server running in the InduSoft Web Studio on the cloud, receiving information from all the RTUs. In the illustration, I just have one, but they have several. Saving data, consolidating the data from all the RTUs in a single database, and InduSoft Web Studio is working as a portal for remote thin clients. But as Matt will explain in his presentation, the previous solutions that they had and the other solutions they found on the market were platform dependent. So they had a solution based on Flash that didn't work on iPads or iPhones, and there were other solutions that depended on the Microsoft web browsers. So they talked to InduSoft, and we helped them design a solution using the InduSoft Studio Mobile Access solution, which pretty much allows you to run the application in a server, in their case, in a cloud-based server, but could be on premises, and visualize the information, the graphical interfaces, on any platform, Windows, Android, iOS, running any browser, Internet Explorer, Chrome, or Safari, with any kind of device, desktops, notebooks, tablets, phones, even Google Glass wearable devices, as long as the web browser supports the standard HTML5 interface. So this is called the Studio Mobile Access from InduSoft Web Studio, fully based on HTML5 to be platform agnostic. Having said that, I would like to welcome Matt Lindemann to the presentation and ask him to share his desktop. So Matt, thank you again for taking the time to co-hosting this webinar with us, and feel free to get started whenever you are ready.
Good morning. Thank you, Fabio. To get started in explaining a little bit about what we do, what we did put together for one of our manufacturing customers, it probably helped to give a little bit of background on who we are, Dakota Fluid Power in general. So a little bit about Dakota Fluid Power. We're a full-service hydraulic, pneumatic, and electronic system component supplier providing comprehensive customer-driven fluid power solutions. Each of our DFP outlets is equipped to provide in-house component system repair testing, component sales, systems engineering, basic machining services, and field services, such as installation, startup, and with the assistance of some of our fully equipped service trucks. Each of our locations is staffed with key specialists qualified in providing the design engineering and the product application advice, much like what we're going to show you here in a little bit. But the real kicker here is that since our inception in 1991, we've always cornerstoned our success upon the one-stop shop approach and providing a high level of industry knowledge in all aspects of fluid power. Not only just traditional fluid power technologies like hydraulics, pneumatics, but also in the electronics portion as well. Additionally, kind of the group that we're representing, or I'm representing, that does all the systems engineering with the InduSoft Web Studio product, was created in 2000. And it was recognized that there was a need that existed among our equipment manufacturers for a uniquely skilled and staffed group that could transcend the current engineering resources that specialize in what was viewed as the brains and muscle of a given piece of equipment, regardless of the type of application. So we're kind of industry autonomous. The OEM division, which is our technology division of the Dakota Fluid Power, was conceived to fulfill that need, and under the premise that we'll staff with quality people to deliver creative solutions with our strong relationships with our OEM customers, and those solutions specifically requiring electrohydraulic integration excellence, including telematics support. A couple of things that I hit on here a little bit was that one of the things is our people, and partnering with some of our vendors is what makes us unique. You know, we understand that there's an ever-increasing need for technically knowledgeable, value-added, and service-oriented partners and vendors to help with development and of advanced systems that keep our OEMs market leaders. So we continue to meet and exceed those market-driven expectations by combining technical competence, product knowledge with competitive, value-oriented pricing solutions. So, seven key things that kind of encompass Dakota Fluid Power's OEM group: be our customer service, our MRP programs assistance, hydraulic and pneumatic system component implementation competencies, or electric and electronic system and component implementation competencies, in-house testing and design implementation application testing. We'll take on a piece of equipment from a customer, we'll test it, we'll evaluate it, we'll run it through near applications specifications in our facility. That's electronics and hydraulics both. Telemetric systems, and our quality. Just a little bit of a list, some general information about our OEM group and some of the testing capabilities and systems and different services that we offer. A little bit more about the application. We started with this customer back in 2006, and at that time we had to recognize that there was a need for remote access to equipment, be it mobile, be it industrial, whatever form factor that decided to take, in a variety of markets. Our market is primarily off-highway. That's where most of our equipment manufacturers are located and that we do business with. So back in 2006, a partner of mine and I decided to put together our own version of telematic systems that allowed us to, in a number of ways, launch a application based on a server out on the web, and with a graphical user interface on the front end, basically a website, allow our customers, at least customers that would like remote access to their equipment, to do various tasks. Maybe it's troubleshooting, maybe it's control, two-way control, maybe it's some sort of operation, maybe it's some sort of data collection or mining, something like that, to give them access to that equipment anytime, anywhere, and some very basic reporting tools. We found over the course of, I would say, 6-7 years, that technology started to be something that was a lot more than what we were able to support. We started to look around to see who could offer that service that we had thought we had pioneered, which truly we didn't. To put together, and somebody that could actually augment and come up with the tools so we could spend our time integrating rather than spending our time designing and developing the functionality to do the integration and provide the service. And that's where we came across InduSoft. and working with Bruce Hallenstein and Fabio, we were able to put together a fairly comprehensive system that represents one of our ag customers. And without any further ado, we'll transition to that application here very quickly, and we'll talk about what it is these individuals do. Okay, here we go. So this particular application would be controlled. It's non-glorified. Basically, what's going on is we're pumping liquid manure for field injection, and current setups require up to 3 to 4 different pumps. What I mean by a pump is a diesel engine, a water pump basically, mounted on a trailer with a control system and a very simple hydraulics. And the current operation is, or prior to placing the InduSoft solution, would be for the operators to, or for the line operators to staff 2 individuals per machine. So if I have one machine located next to my source, my water lagoon, I have one along the lines, maybe a mile down the road, and maybe another one a mile down the road. I have 3 devices, I have 6 individuals, plus I have an individual in the tractor that's trying to run the whole operation. The whole operation was basically run off of 2-way radio and no insight. So optimization of the system was basically heavily reliant upon the 2 individuals at each pumping station to make sure that pressure is coming into the system and pressure going out of the, or coming into the pump and going out of the pump were actually at the highest efficiency possible for the length of hose or tubing that they were pumping this through, either to the next station or to the next tractor. The nature of the application is for those of you that are familiar with the agriculture industry in the upper Midwest, there's only a certain amount of time that you have between fall harvest and frost to be able to do any groundwork. And this product is applied directly into the ground after harvest or after a silage cut, and also in the spring, but primarily in the fall season. So it is a 24/7 operation where individuals get very little sleep, they're fatigued, they're tired, there's breakdowns, and it's a challenge. So keeping people staffed to do these tasks and man these pumps is not easy, and the quality of labor is generally not the greatest either. So when we were approached by this customer to say, is there a better way? And following our model and our process, we guided them through a series of questions and went out to visit their applications numerous times. You know, we stood on site, we watched them run their equipment, we watched how they interfaced with it, we watched the breakdowns, we evaluated the entire thing from start to finish. And basically we came down to the conclusion, well, though it's not desirable to eliminate employees or, for instance, have to dismiss them or just not have them available, it's not necessarily a job that these individuals were happy to do. Staying up 24/7, smelling like manure, and living the dream, basically. So what we came up with is utilizing the InduSoft solution. How do we take and migrate from a platform that we kind of put together ourselves to something that was allowed us to spend the majority of our time to do an integration for this customer, and maybe remove those operators because it's not really necessary. It's a manual set of eyes looking at 2 pressure gauges. They're controlling the throttle of an engine up or down, which basically changes the pressures and changes the flow in the circuits. So we went ahead and developed a full control panel and control system locally for each pump unit that's placed out into the field. And on top of that, we worked to put together this InduSoft solution that you're seeing on your screen that allows the operator in the tractor to optimize his entire operation without the need of having 2 individuals per pump throughout the line. So today's modern tractors and operations this size do have auto steer. This allows the tractor operator to focus on One, he does his AB line, sets his path, and he's driving. The tractor's steering itself, and he's watching this, basically this view that you're seeing right here. Unfortunately, there are no online units right at the moment. It's actually raining here, so there's quite a bit of moisture. They're unable to get out in the field doing the work, but regardless, they're able to set up to 1, 3, or 6 views or individual RTUs in their view in their tractor on a laptop, on a tablet, on an iPad. And we do have some customers that have a 27-inch TV mounted in their tractor cab, and they tap back and forth to watch movies, but we're not supporting that at all. So anyhow, the operator, the key guy in the whole operation is the guy in the tractor. He's at the point of injection. He's the one that's controlling the whole works. He now has the ability to control everything that's prior to him, throttle them up, throttle them down, maintain pump efficiency, which in turn increases diesel engine performance, not necessarily performance, but efficiency, as well as eliminating fatigue and those fatigued operators. They can put them in places, maybe checking lines, cut the need for somebody to be on site 24/7 from 6 to 2, and maybe rotate and alternate shifts where it's a little bit more reasonable for somebody to do that rather than taking your full crew and putting them online and letting them run and maybe get an hour or two of sleep in 24, 48 hours. Now we can transition back here a little bit about how this is hosted. We've put the InduSoft Web Studio out on a cloud server, which allows the users access via our customer's website. It pushes them in, they log in. When they log into their panel, we see the typical Studio Mobile Access view. They're allowed to click on the screens. This is their panel views. Generally speaking, we see a 3-panel view is something being very popular. To dig into the details a little bit, actually we have one machine that's online right now and bypassing. Within the 3-panel view, the first screen that pops up is, and if we look at these individual 3-segment sections, the first section that pops up is the one that the operators in the tractor is going to be utilizing the most. And basically what that is I want to control my throttle, maybe bump it up a little bit, turn it down a little bit on each pump. Maybe you want to send the pump to idle while I raise my toolbar out of the ground so I don't have 3,000 gallons a minute of liquid manure splattering on top of the ground while I turn around. And then when I reinsert my toolbar into the ground, I can hit go to RPM. And the engine resumes the RPM setting that's in the box. We have some statuses of gates. As you can see, this unit is actually moving flow through it. So we have 20, the flow is bouncing around a little bit. And then we have indications on gates. Gates are allowed to bypass or block pumps off in a line. Tractor operator also has the ability to go in and select from a list of RTUs that are assigned by his username. So when we go into the system and we create a user using the InduSoft Web Studio functions, we go in and we admin this for our customer today with plans of transitioning them. But currently we go in, there's a new user in the system or there's a new RTU that's produced off the factory floor, we go in and we assign access rights to each of those users. So I don't need to see maybe my brother-in-law and I are pumping manure. I don't need to see his pumps. I don't need them on my list, nor do we want to deal with the security issues of having somebody else's RTUs on somebody else's list. So the InduSoft Web Studio platform allows us to segregate equipment and users to provide a fairly good level of security. But anyways, this user has currently all these RTUs that they're access. The way we set up our communications driver within IWS is that we have a proprietary serial stream that we send across via the internet. And based on a unique ID number, we're populating a table, and that table is referencing an alias name. So that number may not mean something to the operator, but maybe booster 1 does, or agitator does, or lead pump 1. That means something specific to the particular operator. In this case, I'm not going to select anything, and I'm going to be very cautious of the buttons that I press as somebody is intending to run this line here. Okay, so we do have somebody up and running. There we go. So this individual basically has 3 pumps in the line. There's probably more, but for the sake of this discussion, we'll say there's 3 pumps. We can tell based on the gate status. Though we found that there are some of their customers that are colorblind. Any indication they wanted that was needed, but we were choosing to be green, it needed to be blue. So we'll take you to a couple of the next pages here so we can see a little bit about what we got going on. So in a number of these pages, there's the escalating level of information available. Basically, we keep the operators, we ask them to stay on the first screen because that's where their operation is optimized around. However, we can patch them into more information regarding fuel levels, system voltages, temperatures, pressures, engine hours, water temperature, engine oil. Our local control system that we developed on the piece of equipment itself has already got that information locally to it, and we're pumping an Ethernet data stream out via a cellular network out to the internet to this IWS application. You'll notice that some of these items here read 0 or don't have any value put to them. We're in the process of patching over some older equipment, which we've labeled legacy based on the software revisions. Some of the information is available, some of it is not. A couple of the other things, in addition to the throttle that we're able to do in the application, is engine starting and stopping. So from here with confirmations, I'm not going to press the button, but if I hit engine start, which is this button right here, I hit start. It asks me, are you sure you want to start the engine? We confirm with a yes. The start code goes back and sends out from the cloud server right straight back to the path of the RTU that it came from, and tells the control system the user has confirmed with a security code that this pump needs to start. And a countdown starts with a warning horn for 30 seconds, which the operator can see on his screen. After the 30 seconds times out, the engine fires up and says that idle is ready for use. Engine stop is the same thing. There is no time countdown for that. We press the button. Are you sure? Yes, we wish to shut the engine down. Yes, so another page that's available to us, and you can see the color legend here on the bottom. Oops. 3 gates exist on each of these pieces of equipment to block inlet, outlet, or allow bypass in case something bad happens with the pump where the rotor can't turn or the engine's not working. They can bypass the pump without taking the lines apart. This is just a setup screen. It's nothing that the operator would sit on for quite some time. But basically, they're allowed to increase or decrease the open and close time of each of the gates. Depending on the engine throttle, the way the hydraulics is set up, if the throttle is lower, it could take a little bit longer for the gate to open. If the throttle is higher, it could take a little bit shorter for the gate to open or close. So we give them gate status indications. We give them some pressures in case they close a gate they weren't supposed to or open a gate they weren't supposed to. Now, there's also a prime functionality here that's basically to remove the air from the line with a primer pump, vacuum pump. We've had some additional functionality that we've been able to develop in this application for this customer. It's basically an auto throttle functionality where they're allowed to set the desired operating pressures from the IWS system, which interfaces with our local control system and says, hey, this is where the operator chooses to run these items at. Go ahead and run the diesel engine automatically throttle based on what these settings are. So there's no need to constantly, even for the operator in the tractor, to be looking at his inlet and outlet pressures and trying to optimize the flow going through the system. It'll take care of it for him. Ultimately, I think just to watch more movies, but that's my opinion. And then we're back to the main operating page. Take this back and show the 6-panel view for you. One of the an important thing to note here is one of the important things that we found in starting this venture with InduSoft. One, the technical capabilities and the technical support are fantastic. You could not ask for a better technical support team that's responsive. They've been very, very helpful in assisting us in some of the questions that we've had in developing the application. And when bugs arise, whether we created them or not, they were very, very accessible and jumped right on and helped us out, which is greatly appreciated. One of the other things, too, to incorporate was one of the driving factors in choosing the IWS system or InduSoft Web Studio was the HTML5 compatibility. The system that we had developed prior ran solely on Flash, and as some of you are aware, some mobile devices don't technically run Flash. So the way that we had everything set up and the way that this customer was starting to evolve was the fact that they wanted to use tablets and they wanted to use different things, and they're migrating from a laptop, a ruggedized laptop in the tractor cab, going to tablets and smartphones and all that other stuff. And for us, as a integrator, to trying to develop the tools to develop the integration capabilities to apply to this customer, we just didn't have the time or the resources that we wanted to invest to be able to do that type of thing. And InduSoft gave us the ability to do that. They took the burden, just by having a platform, took the burden of having that compatibility available to us so that we can run device autonomous. I can run it on my iPad. I can run it on my Windows phone. I can run it on my Android, Mac, Windows, PCs. It's not a problem. And that was a huge feature for our customer here to be able to do that, because everybody has their preference in devices. And I may prefer an Android, the next guy may prefer an Apple, but when you tell both those guys that Flash doesn't work and you have to go back to a laptop, you're not a popular person. And this is our one panel view. Currently, we just have an engine running, 3 engines running in a line. What we can assume is that they're warming up and getting started for the day, checking everything out, priming the lines, and getting things put together. So I apologize for not having be able to show you some of the functionality running, much beyond an engine reading in and evaluating some engine information and some gate position stuff. With that, that kind of concludes our little presentation that we have, at least on my behalf, on the IWS system and how we've applied it, how we use it, and some of the things that we do and key in with our customers when we're looking at telematic systems.
Well, Matt, thank you very, very much. I do appreciate you taking the time to share your experience and your expertise with us and demonstrate your system. Hopefully, many attendees here could use your system and reach you at the end. I'd like you to provide some contact information for Dakota Fluid Power. And in the meantime, we would like to open for questions. If anyone has any questions, please feel free to write it on the chat bar or in the Q&A box, both of them on the upper side of your monitor on the WebEx panel. And Matt or I will be more than happy to answer any questions you might have.
And thank you, Fabio, for the opportunity to be able to present.
Oh, thanks, Matt. So one question came in is, on the browser, I didn't see you hitting F5 to refresh the screen. How often do you have to refresh the screen? Do you want to take this one, Matt?
Actually, you can go ahead, Fabio. I can comment. We don't need to refresh the screens. They're refreshing themselves.
Yeah, that's the beauty of it. Exactly. That's the beauty of it. This is a subscription model, so there is no pulling from the browser to the server. The browser shows the graphical screen, and as values change on the server itself automatically pushes updated values to the thin clients, to the browsers, and the browsers automatically update the information on the browser, so you do not have to hit F5 to refresh the screen, and there is not a lot of traffic in the network, because after loading the screen, the only information changing back and forth are values, so very few bytes, and only on exception, only when the values actually change. So if you see on this screen, as RPM keeps changing, the server sends the newer values to the browser, but the 800 for commands, the 0 for flow, the 5 for outlet, in the complete graphical screen, it is very much, it does not add any traffic in the network between the server and the browsers. The browser just holds the latest values, and when there are new values, the server sends the updated values to the client to optimize the communication line as well.
Yes, and one thing to note on this, I'm sitting in a water puddle at a farm show in southwest Nebraska right now, connected via my Verizon wireless hotspot. And this pump is, I believe, located somewhere in Missouri. And I don't know what the refresh rate is on your end, but I'm getting an update roughly every second. And that's a testament to the efficiency that's been put together in the InduSoft Web Studio. Is, you know, there is not a whole lot of latency. And generally dealing with cellular, and these guys, they're in the middle of nowheres. But once you've loaded the dashboard, the data flow from the RTU to the server and from the server to your client is very quick.
Excellent. Thanks, Matt. Another question here, what type of hardware was used and how was the connectivity between all?
Okay, so the hardware we used is basically an intercontrol, is the line of hardware that we use. We use we use mobile rated components. These are all IP ratings of IP67 and greater. We used an HMI display that was programmed via with CodeAssist 3.5. We did all the graphics and everything in CodeAssist 3.5. And everything resides on the HMI, all the machine intelligence, all of the machines, obviously the human-machine interface, all the application program, and all the networking. So it is the network master for a CAN open and J1939 network both. So, CAN open, J1939, and Ethernet. So 2 CAN networks and 1 Ethernet network. One network communicates exclusively with the engine and pulling information from it and telling it where it needs to be and where it needs to throttle and how it needs to throttle and the torque that it can run at and run out to. And then the other CAN network interfaces with our control system, the rest of the control system of the I/O. There's not a whole lot of proportional control. There's a lot of digital. There's a lot of analog input that goes into the system from the transducers, flow meters, and stuff like that. But we design and build all the panels and harnesses in-house and basically apply a wireless modem or telemetry device onto those panels, and that's the Ethernet network that gives that panel internet connectivity.
Excellent. And on the InduSoft side, on the server side, you are running on a virtual server on the cloud, correct, Matt?
That is correct.
Mm-hmm. Yeah. which, by the way, is another point. The server could be running on premises or on the cloud as well. And in this case, since it's a distributed system from the geographic point of view, it made a lot of sense to load the InduSoft application on the cloud. And by doing that, Dakota Fluid Power has high availability on the internet, and does not have to take on the cost of maintaining and keeping the server up all the time. Another question is, how often is the data stored in the database? Frequency to populate tables.
That's a little bit of a difficult question. I'd have to ask one of our developers on that, but we are storing data frequently, very frequently in the system.
Yeah, last time I checked, Matt, we are saving data once a second, and while the pump, while the motor was actually running. Another question here, how can you prevent unauthorized users from connecting to the system?
And I can go back to the main login screen. We assign each of the users, this is the front end of the SMA, each of our OEM customers is assigned a username and a password that they can log into the system with. And we allow the original equipment manufacturer to dictate who has what pumps and where, and we assign access to the username based on, what machines they have in their possession or what machines they're allowed to view. So when you log in, all you see is the pumps that you're allowed to see and nobody else's.
Excellent. Thank you, Matt. So it looks like, another one. How could you tell the system to start collecting data when running?
Can you say that again, Fabio?
The question is, how could you tell the system to start collecting data when running?
I think that was one of the things that our application developer worked with InduSoft on that specific functionality. Fabio, do you know what was done on that?
Yes, actually, in InduSoft we have a very modular interface, and for data acquisition we have, in addition to the standard technologies like OPC-UA, XML, and so on, we have what's called native drivers that implement proprietary protocols. And when we worked with Dakota, they designed in their own RTUs a proprietary protocol which was quite efficient. And InduSoft developed a new communication driver specifically to support their protocols. And the RTUs actually send unsolicited messages to the InduSoft server. So it's another characteristic of the overall system that makes it very efficient from the network bandwidth and processing point of view. Even if you have 1,000 RTUs out there, the server does not need to be pulling all the RTUs. When each RTU is actually running and it starts collecting data locally, the RTU itself takes the initiative to send unsolicited message to the InduSoft Web Studio server running on the cloud from any location where each RTU is, and the driver running on InduSoft Web Studio on the cloud automatically receives all those values, all those messages from each one of the RTUs, recognizes the RTUs, and automatically makes those RTUs available for the web browsers, for the web team clients. So there is no pulling from the server to the RTUs. The RTUs themselves take the initiative to send data, unsolicited message to the server when there is new data to be displayed, and the server simply stores this data and make this data available to remote web browsers when remote users log to the system. So again, the system as a whole, from the RTUs all the way up to the browser passing through the server, was thought out by Dakota to be as efficient as possible to minimize the bandwidth in the network and improve overall performance. Let's see. I think those cover all the questions we had. So, Matt, once again, I would like to thank you very much for taking the time to co-hosting this webinar with us and presenting and showing the application. We do appreciate your business, and the project was, in my opinion, very well managed and executed by you. And I want to thank everybody for attending the webinar and for your questions. One last question before we leave is if we can see Dakota contact information. So everybody can reach you, Matt, if they need to take advantage of your solution.
Sure. Where would you like to, you can post that out on the questions, or I can send that out to the attendees as well.
I believe if you just show the website, what is the web link, we can show them where the website is, and I'm sure from the website they'll find contact information to reach you.
Certainly. Our website is www.dakotafluidpower.com. Again, in there you'll find contact information for various different divisions that we have. We are in the OEM division, and if you'd like to discuss the information regarding the application we just showed you, feel free to give myself a call. Again, my name is Matt Lindeman, and I'll be glad to discuss it. Our 1-800 number is for our Sioux Falls, or our corporate location is listed on the website.
Excellent. Once again, thank you, Matt, and thank you, everybody, for attending the webinar. You all have a great day, a great evening, and hope to see you again in the next webinar. Thank you, everybody.
Thank you.